Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3577. Count the number of computer unlocking permutations. Very good problem, right? It is type of a brain teaser, right? Very interesting problem. So in this problem, you are given an array complexity of length n, right? There are n locked computers in a room with labels from 0 to n minus 1, right? So computer level 0, computer level 1, computer level 2, computer level 3, computer level 4, right? Each with its own unique password. The password of the computer I has a complexity of I, right? So complexity array is given to us, right? So let's say computer 0 is having complexity 3, this is having complexity 4, this is having complexity 5, complexity 6, complexity 7, right? So let's say this is what we have, right? Complexity array given to us, right? And these are nothing but the computer names: computer 0, computer 1, computer 2, computer 3, computer 4, right? Now the password for the computer labeled 0 is already decrypted, right? So this thing is already decrypted, good, right? Is already decrypted and serves as the root, right? Now all the other computers must be unlocked using it or another previously unlocked computer following this information, right? So this is already unlocked, already decrypted, right? So this is nothing but root, right? Clear? Now after that, here what is the information we have following this information, right? So you can decrypt the password, okay? You can decrypt the password for the computer I using the password for the computer J, where j is any integer less than I with the lower complexity. J is less than I and complexity of j should be less than complexity of I, okay? And to decrypt the password for computer I, you must have already unlocked the computer j such that j is less than I and complexity of j is less than complexity of I. Let's understand this line. So let's say this is nothing but j, right? And this is nothing but I, right? Now here I can decrypt the password for computer I, right? Here if you see, you can decrypt the password for computer I. I can decrypt the password for computer I using the password for computer J. So this is my computer J, right? Where J is any integer less than I. So good, just J is less than I, right? J is any integer less than I with the lower complexity, that is nothing but complexity of J, it should be smaller than the complexity of I. Good. If this is the case, then I can decrypt this, right? Okay. So here we have some value, right? Here we have some complexity. Then after that we have some complexity, right? So here this is my j and this is my I, right? So using this I can decrypt this one, right? If the complexity of I, right, if it is greater than this complexity of j and j is less than I, right? So that means that if we have 3 here, then definitely for my I am decrypting the other computers having greater complexity than this one always, right? I am always decrypting those computers, right, placed at I in which the complexity is greater than the uh, complexity with value smaller in j, right? Right, clear? So we are only decrypting the computers, right, where the complexity at I is greater than the complexity at j, right? Okay, but later on, let's say I decrypt this using this, okay, and later on I can decrypt, tell me, I can decrypt this, I can decrypt this also, right? I can decrypt this using this, right? I can decrypt this using this also, right? I can take this as my j, I can take this as my I, or I can take this as my j or this as I, right? My choice, right? I can do it like this. But later on in the future, if I encounter something like this complexity, can I solve it anytime? Tell me, can I solve the complexity of this? Can I decrypt this? I can never decrypt this because its complexity is smaller than others, right? Mostly this one, right? This is my starting point, and with this starting point I can only decrypt those computers whose complexity is greater than this one, right? Not smaller than or equal to this one, right? So from here one thing is clear, that if this value is 3, right, and in other places also if I find any value equal to 3, or if I find value less than 3, right, then answer is never possible to decrypt the passwords, right? Because 3 starting point, we have 3, and using this 3 I can only decrypt those computers with complexity greater than this 3, right? So if there is any value which is equal to 3 or less than this 3, then I can never decrypt all the passwords, right? I can never unblock all the passwords, right? Unblock all the computers, right? So just keep this thing in mind, okay? Right, this is the important thing, right? Now we have to find the number of permutations of 0, 1, 2, and -1 that represent a valid order in which the computers can be unlocked. Starting from computer 0 as the only initially unlocked one, right? Initially only computer 0 is unlocked, right? Using this only, using computer 0 only, I can unlock other computers, right? And definitely for other computers, the complexity value should be greater than this computer 0 only, then I can lock, right? If any value in the other computers having complexity same as this or less than this, then simply say that we can't unblock, right? Okay, so 0 can decrypt this, it can decrypt this, right? But it can never decrypt this one, right? Smaller complexity, right? This can be done by this, right? But with this we can't decrypt anytime, right? We can't never decrypt. Okay, so since the answer may be very large, we have to return it modulo 10 to the power 9 plus 7, and note that the password for the computer with the level 0 is decrypted. And note the computer with the first position in the permutation. Okay, now see this example. So here very easy actually this problem, right? Label 0, 1, 2, right? So I can this as my j, this as my I can easily decrypt this one, right? And later on when my I is here also I can decrypt this, right? So we have 1, we have 2, we have 3, right? This is already decrypted, right? J. Now later on I am only checking this now, j is less than I, right? And complexity of j, it should be smaller than complexity of I, right? If this is the case, then I can decrypt, right? So I can decrypt this one using this, right? And later on I can decrypt this one using this, or I can use this also to decrypt this, right? But order that I am following is 0, 1, and 2 here. 0, 1, and 2, right? Same way I can do one thing na, I can also use this to decrypt this first, right? Possible, right? And then later on I decrypt this with this. So this is the order I am following. So only two ways I actually, right? Here 0, 2, 1, this only two ways, right? 0 is fixed here. Okay, so output is 2. Now see the valid permutations are unlock computer 0 first with the root password, then unlock computer 1. See this value, this side value, it is always smaller than this value, right? Computer 0 with computer 1, computer 1 with computer 2, right? So this value is always smaller than this, right? Because we need j less than I, right? Okay, so this j is means already decrypted. Okay, and also we are checking this complexity of 0, right? This side j, this side I, right? Complexity of 0 is less than complexity of 1, then complexity of 1 is less than complexity of 2, right? We can do this same way, right? Here unlock computer 0 first with root password, then unlock computer 2 with the password of computer 0, right? And here computer 1 with password 0, and here also we are checking this. So only two ways, right? Here if you see in this case, this is decrypted, but I can decrypt this or not. No, no, this value is same as this one, simply return 0. There are no possible permutations which can unlock all the computers, right? So in this case we have to return 0. That's it. And these are the constants. Complexity of length from 2 to 10 to the 5, and complexity of I values from 1 to 10 to the 9. Okay, let's see some examples. 1, 2, 3, this we already discussed, right? So 0, 1 and 2. So here we can decrypt them like this, or we can decrypt like this. Okay, so total 2 ways, right? So here 0, 1, 2, so you can decrypt this, right? And then you can decrypt this using this, or it's your choice, you can also use this. Okay, so this is nothing but 0, 1, 2 in this order you decrypt, or you can choose like this 0, 2, and then after that this 1 using this, right? Clear? 2 ways, right? Okay, now here if you see, if we have something like this now, 1, 2, 3, 1, right, then I can simply return 0, because in this case answer is not possible, right? So first thing that I'm going to do here, I'm going to compare all these values that I have here with this value, right? So if any value is equal to this value or is smaller than this value, I can simply return 0, right? This is the first thing that I need to do, right? But if I don't return 0 in this step, then definitely answer is possible. Then we have to calculate the number of ways, right? So here let's say we have 1, 2, 3 and 4. Here also answer is possible, right? Okay, these are nothing but computer labels, or you can say indexes, right? Computer labels, or you can say indexes, right? So here what are different ways? So this is decrypted, right? After that I can decrypt them using this 0, 1, 2, 3, or I can choose this 0, 1, 3, 2, right? Or I can choose to do first 2 and then 1, 3, or like this, or I can choose 3, 1, 2, or 3, 2, 1. I am only thinking of 6 ways, right? Here only 6 ways are there, right? So always, if answer is possible na, so you will always see that this value is going to be smaller than all these values. So I can actually treat this as my root, and using this as a root I can decrypt all others in any order I want, in any order I want, right? My choice, I can start from anywhere. I will choose this as my root, right? Very easy, right? So there are 6 ways. Okay, so here what is the total length of this? Total length of this is n, and only these two values are changing, right? N minus 1 values are changing actually, right? So n minus 1 factorial is nothing but number of ways, right? So only two values we are really changing, right? So n is 3, 3 minus 1, 2 factorial, 2 factorial is nothing but 2. Here total length is 4, only these three values are changing, 0 is fixed always, right? So n minus 1 I do, and factorial of this, only three values are changing every time here, right? So that is nothing but total length 4, 4 minus 1, 3, 3 factorial is nothing but 6, right? Okay, so this is what we need to do, right? If answer is possible, then we have to just return the output of n minus 1 factorial. Okay, now how we are going to do this, how we are going to calculate the factorial? Factorial calculation is very easy, right? You know 1 factorial is nothing but 1. Tell me what is 2 factorial. 2 factorial is nothing but 2 into, what is this output of the previous case, 1, that is nothing but 2, right? What is 3 factorial? So for 3 factorial you write 3, and what is the output of previous case? Bring it here, you get 6. What is 4 factorial? 4, and what is the output of previous case? Bring it here, 6, you get 24. What is 5 factorial? 5 into, what is the output of previous case? 24, you get 120, like this. Okay, so let's say this is nothing but your result, 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 result. Actually you are updating result every time, right? Now if you have problem like this, 1 2 3, right? Complexity is given as 1 2 3. So with 1 2 3, you know answer is possible, right? 1 2 3 answer is possible, right? If you have just 1 2, right, then only one way is there, right? If you have 1 2 3, then you can start from here, your I loop, right? So initially just take the value of your result. If answer is possible na, you can take the initial value of result as 1. Okay, then here let's say these are the indexing, 0 index, 1 index, 2 index. So update result every time as result into I, right? So when your I is here, so previous value of result is 1 and new I is at 2 index, right? So 1 into 2, so result is 2, right? Let's say here we have 4 and here we have index 3, right? So next time result is previous value of result is 2 into the index value 3, so you are going to get 6, right? Next time here you have, let's say, 5 value and here 4 index, so previous value of result is 6 and now current index is 4, so 6 4 24, right? So this is how you are going to update result, right? And this is actually very, can be very big, right? So we have to take a mode always, right? This is given the problem statement. Very easy. Let's write the code, nothing complex. Okay, very easy problem, just write a bit of tricky, like you have to use your brain. It's a brain teaser type problem, right? Very easy, no need to use any data structure or anything here. We just need to use the brain and we just need to find out what is the trick. That's it. It's a good problem, interesting problem, and this type of problems mostly comes in the interviews. Okay, so mark this problem as important. Int n is nothing but complexity dot length, and now we have to check if every computer I is greater than 0 has complexity of I value greater than the complexity of 0 value, right? So this is the case that we are going to check, right? Okay, so here what I'm going to do, I'm going to run one loop for int I is equal to 1, I is less than n, I plus plus, and here I'm going to check if the complexity of I is, let's say, less than equal to 0, right? So in this case unblocking is not possible, right? So simply return 0, right? Return 0. So we are going to check if every computer I is equal to 0 has this, right? If not, return 0. That's it, right? Check if every computer I has 0 has this complexity. So if not, you can say, if not, unlocking is possible. Let's say unlocking is impossible. Done. Okay, this is the first thing. Next thing, if valid, the number of permutations, right? Number of permutations is simply you can say n minus 1 factorial, right? And here, because 0 must be first, right? Computer level 0 must be first always, right? From here we are starting, right? And you can say, and all other nodes are always unlockable, right? Because 0 is going to unlock all of them, right? If it didn't return 0 anywhere as of now. Okay, so here simple thing that I've told you, take a result. So here long I'm taking, right? Reason is simple, because values can go very large, right? In the end I will change it to back to int. Okay, int I is equal to 2, start from 2, right? Result is equal to 1, means we have 2 length, right? So if we have 3 length, start from 2, right? I plus plus. So here I'm just going to write result is equal to result into I, and here mode. Okay, this is how you are going to update the result, and here simply return the result. That's it. Very easy problem, right? Return int result. That's it. Only 20 lines of code, right? Let's run it and save the code issues. Okay, Good. All the test cases are accepted, right? Let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.